back, T2LTV, Rob Vingerhoets. We're going to look at division, or we have been looking at division. We had a chat about different contexts. I was just writing up some keywords, putting the symbol next to them. I'll just share quickly with you. I was talking about why would that symbol be, we know that's addition, we take it for granted. I don't know why it is division, but it must come from some, I don't know, it could be Hindu, Arabic sort of symbol for it or something, I don't know. But I was talking to the kids about them, and we tend to turn it just 90 degrees. We take one of them for subtraction and just turn it 90 degrees, and that symbol becomes that for multiplication. But where does the division come from? I was just asking the kids, any ideas, what do you reckon? One kid came up with this, and it's a bit bizarre, but I'll just quickly share it with you. He just said, "Well, Mr. V, that symbol there," and he said, "Yeah," and I said, "Well," said, "Look, take that dot away," and he said, "That symbol is subtraction." I said, "Yeah, right, yep," and he goes, "You know, when we were talking about it, it happened in one of our lessons," and he said, "That's a symbol for recurring, which should be in your keywords." So if you've got a like in the calculator, like the 1 divided by 3, it'll just give you a whole line of threes, and on top of the last 3, it might have a dot to say, look, we can't fit in any more 3s, take it for granted it keeps recurring. So this guy said, well, division is just like recurring or repeating subtraction. Great theory. And I said, oh, well, what about that dot? He said, yeah, well, maybe that's just to like balance it out, so it looks okay. So kids, they're just they're unreal. I love it. If you don't ask, you don't find out. Anyway, traditionally, this is how we've gone about division. Let's pick a context that might make some sense. We're waiting to go on the school camp, and the school camp is in 105 days. So we're going to do one of those things where I said conversion is actually a good application of division. So somebody wants to know how many weeks that is. We're looking forward to this camp. We're going to some place, the Sovereign Hill or something. Or so how many weeks is that? So, okay. Now we can do that by repeated subtraction and go 105, take away 7, take away 7, take away 7, because that's where the link is between division and repeated subtraction, the same as repeated addition and multiplication links up. So we have this scenario. How many 7s in 105? Just get that down the road so it's not distracting us. So this is our scenario. This is how traditionally we've taught kids how to do it. So it's been 7 into 1 doesn't go, right? It actually does, because the quick thing you can show the kids is, well, where's that 1 hanging out? And that 7 is clearly 100. I mean, because you say 105, so it's clearly 100. So when we've said to kids 7 into 1 doesn't go, well, it's not 1, it's 100, and 7 into 100 actually does go quite a lot of times. So it's actually been incorrect. It's not accurate to say, we should have perhaps said it doesn't go conveniently, but it sure does go, because in the end, this sum is made up of 3 parts. 100, how many 7? 0's, how many 7? 5, how many 7s? If you get an answer to all 3 bits and add them up, you'll get the answer to that situation. But I think for the sake of brevity, efficiency, we might have thought we wouldn't be confusing kids if we just say doesn't go. Well, with that's fine, but it came at the cost of understanding. And sooner or later that will come up and bite you on the mathematical backside, because understanding is crucial. So this is what we did. 7 into 1 doesn't go, righto. 7 into 10, okay? So 7 into 10 goes once. But it was where the 1 ended up that's really fascinating to me. Like, at least the teachers were pretty keen you put that in the right spot. So the 1 went here in the 10s. So really I was saying there was 10 7s in this 10, and that is 10 hundreds. It's 100, and no 10s, it's 100. Just come back to that point later. So 7 into 10 goes once and 3 left over. And we used to do a shrunken 3. Oh, I didn't mean that to work out exactly as it did. We might make that 107 days. Just as I didn't mean that to be too convenient. So we ended up with how many sevens in 37, and then we went, okay, so how many sevens in 37? 5 there, that's 5, and 2, and then we put 2. And yeah, okay, that's correct. But I don't know how good it is as a method. Actually, I'm being nice, it's not that great at all. But that's not to be taken personally, it's not a criticism, because as we mentioned with subtraction, I think we also multiplication, what more can we do than teach the kids the way that we as teachers were taught? That's how I was taught, and the sad part is that's how we're still teaching them, even though I went to school in the we're still being taught that way. Like, we need to move on. Although having said that, there's some of the methods I'm going to show you. You might go, wow, that's not great. Well, you know, that's fine. I'm not precious about them, but see how at least they're in place value based. So let's take this one. All I do with this one, I make it a bit more about place value. It's a little bit, it's short, it's still short division. It's but it's with a little more sense in it. So I just encourage kids to just remember what we're talking about. So 7 into 100, it goes quite a lot of times, okay? But I'm choosing to call it 10 tens, which is 100. So if it's 100, no tens, it's 10 tens, it's 100. And really cashing in that the 1 goes in there. So what I'm saying is, that's one lot of 10. So I'm saying that means there are 10 sevens in 100. There are. And 10 sevens are 70. So that's the bit that I just did there. So then I get the kids to say, okay, so that means there's 30. So let's put the 70 in. So we put this extra step in to see how far we've still got to go. 10 sevens got us to 70. So I'll just move that a little bit so it's not encroaching. So 10 sevens are 70, so I know that. So I'm going to put that here to see how close I am to 107. There's the 10 sevens, 70. Oh, I'm 37 away. How many sevens in 37? All right, with whatever number facts that you know, you can just flip that around and go, okay, I know 7 fives are 35, so that gets me closer. That's 5 sevens. So here I'm going to put 5, and depending on the context, this is really on 2 days on my way to another 7 days. So I'm 15 weeks and 2 days. I don't think that deserves an R2. I think that deserves a fraction. I'm convinced it deserves a fraction. The remainder business is all about the context. Here the context is a week, and that's better served as a fraction for understanding. So that's you can see it's not much different to that previous method. But it just brings the place value back in, and it's where this line 7 into 1 doesn't go. Well, it's 7 into 100, and it does go, but I'm choosing to work with it as 10 tens or 100, and let's go 7 into 10 goes once, but it's where the 1 goes. It's in the tens. So that is saying that there are 10 sevens in 100, and 10 sevens are 70. Do it as a subtraction problem. It's always going to be a simple multiplication fact. So it's 107 take away 70. Write it. Instead of this, you got this. And this ensures the place value. So it's shorter. It does make more sense to kids. Or you can go take it right back and do those 3 parts. And when the sums get more complex, that becomes very difficult. All right, so that's shorter division. Not short, but shorter. Okay, we'll show you another method very shortly.